Hello, our students. This is the second lecture on rocks. We will continue talking about different kinds of rocks and how they are formed. Okay, how rocks change. We were talking last time about, the rock cycle, and we have seen that one type of rock can change to another type without going through a specific path of our direction. And now we will be talking about how these rocks are changing from type to type, uh, which is happening slowly, because it cannot be done like that, changing suddenly or abruptly. Uh, Rocks change from type to type very slow, and this I can give you an example about changing slowly from type to type. If you have for example, if you have an igneous rock, then you have many processes to happen to affect this rock to change it from igneous to sedimentary. For example, if you have an igneous rock, then you need weathering, then you need also erosion process. After erosion, you need transportation, you need sedimentation, you need compaction to change from igneous to sedimentary rock. Okay, so these rocks, or the way rocks change, depends on various processes that always taking place on the surface or under the surface of the earth. Okay, we will see the first two factors, heat and pressure, which they affect rocks and change them from one type to another. Usually heat below the Earth's surface. Temperature are very hot or hot enough to melt rocks. And also, for your information, that you need from 600 to 1300 degrees to get the rock melted. Uh, Before melting, we need to know that the rocks can be changed to another type of rock, or rock can be changed to another type of rock even before reaching the melting point, which means that in the solid state, the rock type can be changed to another rock type before melting just by heat. Okay, and this will change from one type to another without melting. The other factor is pressure, and pressure is additional factor that affect transforming rocks, and this is caused by accumulating tons of rocks on top of each other. And usually we find heat and pressure all the time, or most of the times, are together. Okay. Okay, so as we see from this figure now, heat and pressure usually work together. They are friends always. Whenever you have heat and pressure, whenever you have heat, you have pressure all the time, or most of the time. This kind of change is called metamorphism. Metamorphism, which results in metamorphic rock. And metamorphism actually is two parts of this word, meta and morphism. Morphism is coming from morphology, and morphology is, the outside shape of the rock. Okay. The second couple, or second couple of friends, we call them melting and cooling. Melting, of course, melting comes from high temperatures, and it happens usually deep in the earth. And believe it or not, you need from 600 to 1300 degrees to melt a rock. And you, now in this case, you changed that rock to a substance called magma, or molten rock. And then we come to cooling. Cooling magma changes this liquid, or this molten rock, to a solid rock. Imagine that if you have this magma coming from very hot magma chamber, uh, pushed to the surface of the earth with very high temperature, and suddenly it cools down. Any rock that forms from cooling of magma, we call it an igneous rock. And the magma that cools quickly from one kind of igneous rock and magma that cools slowly forms another kind. So you understand this? It's the same magma, but if it cools very slowly, it gives me a type of rock, and if it cools very quickly, it gives me another type of rock. We will come to this point later on. Okay, so if you have all this magma pushed up to the surface of the earth, then from the deep it explodes out as a volcano, and we change its name from magma to lava. So magma is inside the earth and lava is outside the surface of the earth, and it cools very quickly. And in this case, we call all this kind of rocks are extrusive igneous rock. We know it's igneous rock, but now we call it, we classify this as extrusive. Extrusive means something comes out of the surface of the earth, coming from exit. So X from exit. Extrusive igneous rock. It extruded or pushed out of the earth and cools outside very near to the surface, or very near. So we call it extrusive in two cases: if it is outside the surface of the earth or near the surface of the earth, very near. How about intrusive rock? The opposite case. If this magma doesn't reach the surface of the earth, we call it intrusive. So imagine in this case, this magma does have long time to cool down. It is different from the other type. You remember we have those extrusive rocks. They cooled very quickly because they are just running from inside the earth to outside, and they didn't have any chance to cool down slowly, so they cool down very quickly. Now intrusive rocks, magma that cools at a much slower rate than lava. And in this case, we call the type formed is intrusive, not extrusive. Intrusive igneous rock. It intrudes or pushed into the earth's interior, so beneath the surface. Remember the difference here? This is beneath the surface, and for exclusive case, it's outside the surface or very near to the earth's surface. Okay. Next couple of friends: weathering and compacting. Weathering usually happens by rain or wind, and this causes rocks to get eroded and broken down to smaller pieces. We know that. And these small pieces of rocks form sedimentary rocks after, of course, transportation and compacting and stuff like that. So compaction or compacting, as these little pieces of sediments get compacted together, they eventually call or form the sedimentary rock. So now we can talk a little bit in detail about each type of those rocks very quickly. Types of rocks, the three main types. We have sedimentary, metamorphic, igneous. All of them are formed, and we can classify them on how they are formed. For example, number one, sedimentary rock formed from particles of sand, shells, pebbles, and other fragments. and you can see sand, pebbles, fossils, or stones in the rock, as you see in the figure on the right side. And examples of those rocks are conglomerate and limestone. Okay, I will leave you now, and we will meet for the next lecture about sedimentary rock and metamorphic rock. Thank you.